Astronomers have been trying to figure out little red dots spotted in an early image of the universe through the James Webb Space Telescope. Now, a new study says they could be dark matter stars. Did scientists just find clues to life on one of the icy moons of Saturn? And what breakthrough did a first-year grad student find out about rain on the sun? Explore these topics and more on Surveying the Cosmos.
T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0.
Hi everyone, I'm Eric, and welcome to Surveying the Cosmos, where I'll get your space news and more real fast. More tantalizing proposals are trying to explain the mysterious little red dots, or LRDs, that were found on the James Webb Space Telescope at 280 million years after the Big Bang. First proposal was that the LRDs were fully formed galaxies in a time where the universe's first stars haven't even formed. In the last episode, I talked about another proposal that these little LRDs are black hole stars. Now, a new study published in the journal Proceedings of National Academy in Science believes that at least 4 of these LRDs could be supermassive dark stars. These supermassive dark stars are as bright as an entire galaxy, but they are primarily composed of pristine hydrogen and helium being supported by the gravitational collapse of very small amounts of self-annihilating dark matter inside them. Dark matter composes 25% of the universe, but its nature is very elusive to scientists and astronomers. It is believed that dark matter has particles that, when they collide, produce heat, thus converting the clouds of hydrogen and helium into bright, shining dark stars. These dark stars could be the seeds of supermassive black holes of the early universe, powering many distant quasars observed by astronomers. More observations are needed to figure out what is really happening at the birth of the universe. The possibility of life existing on Enceladus, one of Saturn's moons, presents an intriguing subject for scientific inquiry. NASA launched the Cassini spacecraft in October of 1997 for Saturn and its family of icy moons. What it discovered over its 20 years has been phenomenal, and we are still decoding its findings 8 years later. Published recently in Nature Astronomy, scientists have found new complex molecules that have been spewing into space from Saturn's icy moon of Enceladus. Enceladus is the 6th largest moon on Saturn, the 19th largest in the solar system. It is covered by fresh deposited snow that is hundreds of meters thick. Temperature at noon is a warm minus 324 degrees Fahrenheit. The Cassini spacecraft discovered over 100 geysers that shoots jets of water vapor and other materials into space, some of which fall back on the surface as snow. Cassini discovered evidence of a large polar subsurface ocean of liquid water that is around 6 miles in depth. Scientists believe that these newly discovered complex organic molecules is a clear sign that complex chemical reactions are taking place in the underground ocean. These findings lead scientists to believe that Enceladus is habitable. It checks all the boxes for an environment that supports life: liquid water, a source of energy, and specific chemical elements and complex organic molecules. These findings are valuable for planning for future space missions dedicated to this icy moon. When I finally have some time to do astrophotography in the night sky, the last thing I want to do is see a chance of rain. Liquid water falling from the clouds in the sky. But did you know that astronomers are struggling to figure out how it rains on the sun? It's not water vapor, but cooler, dense blobs of plasma falling back on the sun, known as solar rain. It appears that the explanation on how solar rain works has been cracked by a first-year grad student named Luke Benovitz, with his work recently published in Astrophysical Journal. Past models made assumptions that the abundance of plasma was consistent in space and time. However, coronal condensations formed due to the formation of areas of abundances that fluctuate in various regions and over time. As these area abundances of plasma form, heat is radiated and the cooler blobs of plasma rain come down on the coronal surface. These findings will help solar scientists better model the sun's behavior during flares that can lead to better predictions on space weather that depicts our lives here on Earth. In today's Did You Know segment, did you know that out of 417 known moons in our solar system, 6 of them are classified as icy moons? An icy moon has a surface mostly composed of ice and may have an ocean underneath its surface. Due to gravitational forces with its planet and/or cryovolcanic activity, these moons are believed to harbor liquid water below its surface. These 6 icy moons in our solar system are Europa orbiting Jupiter, Mimas, Tethys, Dione, Rhea, and Enceladus orbiting Saturn. With 6 icy moons and oceans below their surface, do you think that they contain life? Let me know in the comments below. Thanks to all my new subscribers for joining me here at Surveying the Cosmos. We've just busted 1,000 subscribers. I'm grateful that you have joined me here and learning together about our amazing universe. Until next time, take care and clear skies.
T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis.